Jamie, thanks for taking the time today. Really good to see you. In short form, what was the path you took to get here?
Wow, that's a great question because you never know what opportunities in life come before you, and you just have to take advantage, seize the day, as they say. There was a gentleman named Andre Yanku. He's from the West Coast, Los Angeles, and he asked me to join because there was a lot of things to get done. It was like the USPTO had been left in a time bubble, like around 2000, and the internet age just passed them by in a whoosh. So we're trying to catch up right now. It's great foundational software from a client server perspective. But as we all know, there's a lot of advantages to moving to the cloud, which have surpassed the USPTO. So we're trying to modernize our systems and bring them up to the internet age and take advantage of all the new innovations.
So is it kind of fair to say you're in kind of classic mode, client server, data center centric, firewalls, application distribution controllers, that world has served us all well for the last 25 years. Now you're moving to cloud native.
That's exactly right. And with that comes all the headaches, right? Client server is synchronous for the most part. How do you produce asynchronous listeners and event handlers that don't really have any place in the old client server world because everything was, you knew what was coming in. Now you have to plan for things you don't know of, chaos engineering. So we've started a lot of different resiliency efforts, especially for the fact that we're staving off our monolithic architecture. We have very huge, big, massive applications. And what we need to do is starve them off and go from stack to stack and just take them, stave them off, and create some microservices that can be replaced in the future. Maybe it doesn't have to be, but we have to get to that point that we can go at it in an incremental fashion instead of the Big Bang theory.
A lot of people are using the strategy of wrap or encapsulate what's the current existing infrastructure, and then everything new, making it modern cloud native. Is that your approach?
Pretty much. I don't want to say it's all that approach because there's always room for adaptation and innovation. Maybe we'll go off and do something else, but for the most part, that's what we've done. In fact, we took an old IBM architecture and they don't support it anymore. And we encapsulated or containerized it to the point where now it's its own property. It's a black box, but we need to replace it. We need to get inside and figure out all those business rules so that we can take them and use them elsewhere.
Yeah. So security and reliability are the key. I mean, those are the two things. You talk about resiliency, but it kind of comes down to making sure that it's reliable, available, and making sure that it's secure. And so you've got a lot of efforts going. How many developers do you have that are working in cloud native modern app world, roughly?
We probably have over 1,000 developers, and that includes our federal staff along with our contractor staff. But that's about right. We have over 100, wow, over 100 DevSecOps teams that are doing product development, no longer doing project management, but rather product management. And in that product world, the business owner actually owns the product team and makes those business decisions right next to the technical architect who's there supporting and providing the ability and the capability and explaining that in business terms. So it's really a business and technical partnership rather than throw it over the wall and see if it works.
So Mark Andreessen said probably about 10 or 12 years ago, he said, software is eating the world. And software, which is pure innovation in so many ways, is eating not only the world, but the USPTO as well.
Oh, there's no doubt about it. I mean, just for the fact that you have a checklist and you can do 10 things, but of those 10, you might be able to automate 4 or 5 of those steps. And so you can use RPA. We're using UiPath right now. There's others out there that you can do, but we found a lot of business processes that were manual, swivel seat and all that other stuff, 100 monkeys typing in all the fill in the forms. You could automate 4 or 5 of those 10 steps and you get real great efficiencies and cost effectiveness. Not only that, but time. The biggest thing in the government that I'm trying to fight is a sense of urgency for time because, oh, don't worry, we'll get to that later. No, time has money. Delay has cost. People sitting around doing nothing, waiting for a decision from on high is not the way to produce efficient code. You need to move forward and produce something, get some results. If you're waiting for a decision on a business function, then what you need to do is upgrade, get rid of your technical debt, make sure you're secure, and do all those things while you're waiting for that decision. Don't sit idle.
No, that's a very good point. And what we always attempt to do is tell people, don't wait for a lot of decisions, do something, get it out in the wild, and you define what your wild is, and then get some feedback on it. Because a lot of times decisions from on high aren't very well informed. And you got to get them, you got to get a lot of data, and usage is data. So, okay, software's eating the world. You got about 1,000 developers. Secure software development lifecycle is a really hot topic, starting with SolarWinds. Everybody sort of got that the attackers were developers, and they understood shifting left probably better than many of your 1,000 developers did, because you're kind of like a lot of development shops. The attackers said, if I can get left of the security in the development lifecycle, I will own the whole lifecycle. And they did, and they did for a long time. What are you thinking about secure software development lifecycle? How many software development lifecycles, or we call them, CI/CD pipelines or whatever it is, those aren't necessarily secure. That's just a label. How many of those are there in USPTO? Have you standardized? Do you have one now, a canonical process that you cause everybody to use?
So there's, of course, a pattern or a methodology. And I do want to say there's a way forward, the old Mandalorian, this is the way. But the fact of the matter is you can't just say one way and put those, again, monolithic standards. You must comply. The whole thing with security is you need compliance, but it needs to be adaptable, agile, and flexible. So in that case, then, architectures need to be big, medium, small, the simple, complex. There needs to be the ability to choose the right architecture for the right function. Heck, a $500, $500 million, they're different. You need to approach things differently. And that goes with the architecture as well. So our DevSecOps teams are by product category, right? So we have 4 product lines within the USPTO: patents, trademarks, back office business, and IT infrastructure. Of course, the last 2, back office business and IT infrastructure, they have shared services that both patents and trademarks use. Funny thing to note, business-wise, we are not taxpayer funded. The USPTO is totally fee funded. So I don't have a fiduciary to our taxpayer. I have a fiduciary to the nation's fee payers, those guys that pay the fees for trademark register and patent application. So I have to make sure I'm using my money the most efficiently. And in order to do that, the product owners are figuring out what needs to be done at that time. And so an architecture that's very heavy and costs a lot of money for a little small function doesn't seem right. It's not responsible. And so you have to apply the right tool at the right time to the right place.
Well,
I think that's, yeah, go ahead.
No, I was just going to say, I would agree with everything. And I would add that when it comes to securing these applications that you're building, which in some cases are, hold in them some amazing innovation, crown jewels, new ideas, things that want to be trademarked, you are being attacked all the time. Security isn't variable. Security's got to be the same high bar across everything, correct?
That's not true. So this is really good. I'm sort of a Jekyll and Hyde with our data. And what does that mean? Before the data is submitted, it's public information. As soon as that data is inside, it becomes non-public, proprietary to the applicant. But as soon as we award or reject, register, then it becomes public again. So at either end of the spectrum, I have an obligation to make sure everything's public. But when it's in process, that's when I have non-public data that I really have to ratchet down and make sure nobody else can attain. You know, the Snowden adventure is a great thing in security because system administration was allowed to cross throughout the entire enterprise. That has to change. We need role based security. And so we're developing that type of security within our new cloud applications and anything we refactor. We have the security part of DevSecOps way to the left, as you're saying. We actually have the security engineering in our developers. If they're not thinking about security, they're not doing their job right.
So interesting you brought up Snowden, because that reminds me of something we're going to do in a later version of this interview series that we're starting today, which we're going to talk a little bit about machine identities. But Snowden actually compromised machine identities to get lateral movement within the domain he was working. And that's really interesting because you can go from a low security requirement environment and transverse it laterally if you're not set up correctly to something else. All that has to be taken care of in the software development lifecycle, because what a lot of people will do is they'll hard code in credentials or they'll not use least privilege. And so that's kind of got to be standard for anything that can touch anything else. So I understand what you're doing is you're segmenting, and within those segments, you're doing the appropriate thing. You know, and that brings up something else that has been one of the hot topics in Washington, D.C., which is software bill of materials. And what are your just sort of initial summary thoughts on software bill of materials and how that applies to securing the development work that you're doing?
You know, the old adage of the road to hell is paved with good intentions. And I just say that because I love software bill of materials, because it identifies everything that's in that package. But the question then is, if it's not automated, if we can't use our tools to get there, it just becomes too much of a burden. So it's not the what, it's the how. How are we going to use this to our effect? If we can't timestamp it with a signature, that exact software bill of materials, it might not be valuable because you're verifying something that's old and not updated. I think that's where SolarWinds was at too.
That was in the case of SolarWinds, there was an implication around the provenance of something. It wasn't always clear that it had gone through certain steps and hadn't been changed after it had gone through those steps. So you're right, software bill of materials, it's a lot about once something has been validated and has passed some tests to make sure it hasn't changed, whether it goes into repos, comes out of repos, goes through the pipeline. Another thing about software bill of materials is that it can apply, and you said when software is released, and that sort of harkens back to classic, because if I'm not mistaken, you're in continuous release, right? You're doing a lot of things now, cloud native, which is nowhere, shape, or form like the monolithic apps that we used to release, the .exes and the tar packages. Now it's a service, and somebody comes to it, and that's underlying software that's driving the service can change 10 times in a day if required.
See, and that's the cultural change. That's the mind shift. You really got to get inside the mind. Command and control versus decentralized. I love the whole fight or flight. And why do I say that? When you actually are controlling everything like the FAA over American airspace, there's quadrants. Everything is so structured and rigid. That's not what we're doing. We're actually getting out and like a free zone battlefield. When you have dogfights, there is no control of the ATC. Everybody's out on their own, and they need to make sure they look at file friendly or fire against enemy. You have to be checking your own. That's why the fighter pilots are so key in that battle. They're not relying on ATC for structure and actually winning the battle. It's all up to the pilot and the Rio, the actual navigator, to make sure that they're doing the right thing in that cockpit. And so that same thing goes to the developers, DevSecOps. You need to know and make sure you've got your guardrails going and you're not killing your own people in the process.
That's fantastic. Hey, Jamie, it's always good talking to you. Thank you for taking the time today.
Thanks, Jeff. It's always a pleasure talking to you. It's really great. It expands the mind.